Let's move on.
Okay. Thank you very much for this very kind introduction, Atira, as well as for putting this workshop together. So we are very happy to join this initiative, and we are very excited about strengthening our collaborations with the SRMIST. So this is, may I present some slides now? Is that okay?
Yeah.
Okay. I just
It's
need
okay.
to
It's
share
okay.
something. All right, I just need to share this here. And can you see my slides?
Yes, perfect.
Okay. All right. And I appreciate the time and availability of the chair and deputy chair of the department. So I know you have a busy schedule, so it's very inspiring for us that you can join this meeting. So my name is José Santos-Victor. So Atira already made a very nice presentation. I'm the founding director of this lab, but we have a very flat organization. And what I will try to do in the next minutes is to give you an overview of our activities so that we can know each other better. So we are part of a research center, the Institute for Systems and Robotics, which is actually the largest research center in the area of robotics in Portugal. And then this research center is also part of another even bigger research center where we tackle very multidisciplinary challenges. So this is the Associate Laboratory of Robotics and Engineering Systems. And for example, we team up with people that are working in the energy sector or in public policies or climate change, sustainability, and we try to complement these different disciplines. And as it was mentioned by Atira, so we are affiliated to Instituto Superior Técnico, so we have the same part of the acronym IST in the Portuguese side and in your side as well. That is a part of the University of Lisbon. So this is the largest engineering school in the country, and I would say the most reputed one as well. And we have, of course, a good. We are among the top. I think it's 75, depending on the rank, engineering schools in Europe. So the outline is the following. So I'll give you some numbers about our lab, then I'll go over quickly over our main research topics and some highlights so that you can get a perspective of what is happening or what has happened recently on our side. An aspect that we attach a great deal of importance is the experimental test beds. So we have been designing, building, and maintaining sophisticated infrastructure that we provide to our team members to carry on cutting-edge research. And of course, this is always based in a set of external collaborations with companies and international academic partners. And of course, this collaboration with SRMIST is a very good example of these activities that are very important for us. Is this okay, the sound? Can you hear okay? Yeah? Okay.
Yes.
Okay. So if you need me to stop or ask something at any point, just interrupt me. Otherwise, I will go on.
Yeah, please.
So some numbers. So, okay, thank you, Atira. So in the lab, we have, so these numbers are always changing, but we have in the range of 10 to 12 researchers with a PhD. So some are faculty within IST or other schools in the area of Lisbon. And we have research scientists or research faculty, around 5, 6. So these are more or less the numbers that we have been maintaining in the last few years. So we have a good deal of PhD students from very bright PhD students from all over the world. So one very good example is Atira Nambiar, that we were happy to have Atira with us doing her PhD. And we learned a lot with our bright PhD students, and Atira was a fantastic example of that. We have one research engineer that has the difficult challenge of keeping the robots alive because they tend to be fragile here and there. And within the group, we award in the range of between 2 and 3 PhDs every year. We publish between 15 and 20 papers every year in international journals, and slightly more in the conferences. And we do manage to attract a reasonable amount of research funding. So in the last 5 years or so, we have been raising more than €500,000 per year in competitive grants. So we spend a lot of time in this activity as well. So some highlights in last, so I mentioned, so we have awarded about 17 PhD degrees in the last 5 years. In many cases, these PhD degrees, they include international collaboration. There are dual degree agreements, for example, with the University of Carnegie Mellon in the US, or EPFL in Europe, or UFES in Brazil, Belgrade. So we tend to promote this possibility that our students spend part of their time in other academic friends, and therefore they get exposed to other ideas, and this is also a way to promote our collaboration. So we do a lot of activity to get involved in these large projects funded by the European Union, by European Space Agency, sometimes directly by companies like Google, NVIDIA, and this is important for us because without this funding, then the activities would be severely reduced. We have created these research infrastructures over the years. So one of the, let's say, most visible is perhaps the robotics brain and cognition research infrastructure that is part of the Portuguese roadmap of research infrastructure. So it's a selected number over the country, and this is the only one in robotics and AI, so connected to cognition. And this is led by us. And I mentioned already the involvement with companies. So in terms of research topics and highlights, so I will give you a crash view, a crash tour of what is happening on our side. So it's always hard to try to organize the research. So research is very dynamic, as you know. So the topics keep moving, and regularly we try to find a way to provide a landscape view of what are our activities. And I would say, so this is the latest vision that we have. So our main activity is computer vision, and it's a lot related to the aspects of human activity and scene understanding, so developing algorithms in this general sense. And then it gets substantiated or materializes in three focus areas. So one is visual navigation and calibration. Robots that move around indoors, outdoors, and they have to navigate and keep calibration operational. We do a lot, so Atira mentioned this. We have, since our foundation, we have kept this tradition of having a close relationship with biological systems. We try to understand biological systems by designing artificial models for them, and in this way as well, we try to get more performing artificial systems. And then there is the part of cognitive robots that interact with humans, human-robot interaction, human-computer interaction, learning. And there is also in these areas, of, in several cases, our applications have been directed towards biomedical systems, as you will see in a moment. So what I will go now, I'll go over these bubbles and provide you with a few examples of what has been happening over there. So these are examples of projects in the area of visual navigation and calibration. So many of them have to do with autonomous navigation, so vision for identifying objects in the street. We have worked quite several projects with aerial vehicles, mostly on the perception part, the vision and hyperspectral cameras. And here we have addressed applications like forest fires, or monitoring the coastline of Portugal, or monitoring critical infrastructures like dams and bridges. And we use these drones and cameras and sensing and for monitoring these infrastructures. So this is one strong research activity. Had different projects with with defense and industry. We provided data sets that are now used by a broader community to apply machine learning. These are the examples on fire detection. This is the example of the surveillance of our marine coast for pollution and vehicles. And there is an interesting project here also for cave exploration, underwater cave exploration, where we use vision for the 3D modeling of the environment underwater. And this is used to help the divers when they are exploring these structures. So in the bio-inspired system and models, so we have, for example, worked on non-verbal communication between humans and robots. So humans communicate even without speaking. This is what is called non-verbal communication, by moving their heads, their eyes, pointing, and so on. So we do experiments with humans. So we instrument humans, we measure this secret language, and then we try to use machine learning to learn models of non-verbal communication from human-human interaction. And then we try to transfer these models to robots. I believe there will be, so we will see in the presentations in these 2 days on our side that you will see some glimpses, more detail on this aspect. We have been working closely here with neuroscience to try to understand how in the human brain actions and objects are represented, and how do we humans use these to perform robustly and to solve our challenges in a data efficient mode, if I can add. This is an example of the affordances, and we are also trying to understand better the oculomotor control, because again, in close connection to neuroscience, to better understand aspects that are not fully, still not fully clear in research. So these are some examples. Maybe I will have to move fast. This is a model of the human eye where we are studying the oculomotor control. These are gadgets that we use to measure human gaze data that is used to create these models, and then they are tested in our flagship humanoid platform that is the iCap. It's the most sophisticated humanoid robot in the world in terms of mechanical degrees of freedom. It's an outcome of a large EU project. We have designed the head of the robot, plus some of the vision and machine learning. And we have one of these guys in the lab. In the area of cognitive robots, learning and human robot or human computer interaction. So I've mentioned this robotics brain and cognition research infrastructure. We now have a nice project where we are connecting robotics and AI with the cultural heritage. I think this is a very interesting area of application of our domains of robotics and vision and robotics. And the challenge is, it's a large European project, and the challenge here it's in Pompeii, in Italy. So there was the Vesuvio, there was the eruption of this volcano, the Vesuvio, about 2,000 years ago, and this Roman city, Pompeii, totally collapsed. So the fragments of the paintings on the wall, so the frescoes, so they have millions of small fragments of these pieces that were recovered by archaeologists, but there's no way we can have the human power to rebuild the puzzles, to reconstruct these frescoes, so that people can again enjoy this cultural heritage. So these assets are basically stored in storage, let's say, sort of warehouses, and they are not accessible to the public. So what we want to do is to bridge this gap and use robotics and vision and AI to finally bring this cultural heritage to become again accessible to humans. We are part of a large effort here in Portugal, the Center for Responsible AI, so connecting with large companies in different sectors, startups and research centers, where we want to develop AI systems in a fair way, for example, reducing biases and negative impacts with the minorities, so that there are different aspects that are being, so in order to develop more trustworthy AI systems and that this technology is not evolving in the wrong directions. This is a very large effort that we are participating these days. So still in this area, we have had different projects connected with in the medical area, for example, using robots to assist older people. So this is a line of research over a number of years. So in Portugal, we have the population is getting older, so we have a large fraction of older population. Unlike India, where I think the demographic pyramid is much more towards the young generations, and therefore we are providing technologies trying to assist this population. So we developed some systems that gave origin to patents that we have licensed with some of our spin-offs, for example, for cognitive and physical stimulation of the old populations. So this HAVATAR project is a tele-autonomous robot for healthcare, where you can recruit, let's say, remotely participate in the activities in your job or at your university, research center, wherever, even if you cannot go there in person because of some health condition. So other aspects have been in the area of skin cancer. There has been a large sequence of projects where basically we are using machine learning algorithms to help diagnosing and monitoring different types of diseases, in this case particularly melanoma patients, where we do have the concern to develop transparent algorithms so that there is some degree of explainability in these AI methods. And this is also another project with CMU, Carnegie Mellon, in the area of health, where we are integrating different data in the medical hospitals and try to improve the diagnosis and tracking physiological variables of different patients. So there have been a number of PhDs. I just want to, these two have been finished this year. I just want to show here the picture of Laura, so she will present her recent work. And we have the Now robot that we have been using, the same as you. And this was to assist in therapy involving autistic children. But Laura will tell more about this in later on. So over the years, we developed different research platforms. This is our first, let's say, humanoid robot, even it has no legs and only one arm. This is Balthazar. Then we participate in this large effort to build the ICAP, where we were responsible. So the legs and the torso was designed in the UK, the arms and the hands in Italy, and the head was designed in Portugal. And there are 50 copies, 50 something copies of this robot all around the world. And we share the algorithm, so it's a common infrastructure where we can build on top of what the other teams develop, and then we share our algorithms and software as well. So this is Vizi, our social robot that it was entirely designed at home. So this is a good friend of Atira. And we use it a lot for indoor navigation, interacting with older people. So whenever there is this social component, we have the Now robot, and a few other manipulators. This is the platform that we've developed that is now being deployed in senior homes in different places in the country for the physical and cognitive stimulation of older people. We have eye tracking devices. We are working quite a bit with the VR and AR goggles with different sorts of hands. We designed our family of hands for Balthazar, also for Vizi with touch sensing. This is a soft hand that we are using to grasp the 2,000-year-old frescoes. So the archaeologists are not very happy if we damage these fragments. And we also spend a bit of time to expose, to talk to in outreach activities, to talk with the new generations, to explain why science and technology and robotics and AI and what we do is important for the society at large, particularly towards girls, because the girls are not always, so the number of girls that are working this area is still much less than that of boys, so we want to try to balance this. So in terms, so we nurture a vast number of partners all over the world. These are partners in our, let's say, projects, partners in our ecosystem where we train our doctoral students, our master students. We have a very large number of master students every year. I didn't specifically say the number, but several tens of master students working with us in the lab and with a lot of enthusiasm. And this is also very important for us because I think it's very important for research to share these ideas and this collaboration that we have with your institute, and that we are trying to make the links closer and closer. I think it's very important and encouraging for us, and we are very happy to support everything. There's a good deal of people that have been doing this work all over the years. Atira's picture should be here as well. We need to correct this. And that's it. So it's well, it's a little bit fast, but I hope I gave you an overview. So if you have any questions, I'm happy to address those. Thanks a lot. Okay. I think you are okay now. We listen.
Yeah.
Maybe I was a little bit fast, but you will see more detail in the subsequent presentations anyway. I'll explain you Laura, Nuno, others, João.
Okay.
I have just one question.
Yeah, sure.
So, university, does it provide any other internship opportunities that include a collaboration between SRM and this Institute for Systems and Robotics in Lisboa?
Sorry, can you repeat slowly because the sound is not spectacular? If we can provide something for the collaboration between, yeah, but I didn't fully understand the question. If we can provide what? What was the question exactly? Sorry.
Okay. Are there any internship opportunities in the form of a collaboration between SRM and your university?
Okay, you mean opportunities to collaborate in more concrete terms? Is that the question?
Yeah.
Yeah. Okay. Thanks for the question. Okay, I think we do offer internships at different levels. So we involve in our research activities sometimes our bachelor students. So we have a 3-year bachelor plus a 2-year master and then the PhD. And we start engaging the students very early, sometimes in their second year, first year is not very common. And we do provide internships for this mobility of students. And I think this is something that could be, I think it's the best way to materialize these collaborations, to have students going back and forth and transferring the ideas and contaminating each other with inspiring ideas. So yes, this is something that we could set up, and probably it's the best way also to go one step further in this collaboration. Thanks for the question that allows me to highlight this aspect.
Thank you.
Hello, good afternoon, sir. Hello, good afternoon, sir. Hello.
Hello.
Can you hear me? Yeah.
Yes.
So
Loud and clear.
could you tell us what psychology related work you are doing? Like,
with psychology.
yes, psychology.
Yeah, well, with psychology, so most of our activities have been related with what we call developmental robotics. So what we have been pursuing for many years is, well, one aspect is to understand how human babies develop since birth to about 2 years of age. and we try to understand the different aspects of sensory motor coordination, learning about objects and the physics of the world, social interaction. So a lot of this is happening in our first 2 years of life. So we
Right.
work closely with the developmental psychologists to try to model this in humans, and then we try to transfer this to our algorithms and robots. This is one aspect. Other aspects
Okay.
have been more close with the, for example, in the medical area, clinical psychology, for example, for
Right.
diagnosing dementia and these kind of diseases
Okay.
from eye tracking information, for example.
All right.
But we
Thank you.
attach a lot of value to this collaboration with psychology and neuroscience and this multidisciplinary view of the research. I think it's very enriching.
And what about like, have you ever tried like using a robot for teaching? Uh, is that something that you tried to do?
For teaching, not yet. I think the closest aspect may be that I would, well, for teaching certainly not in the sense of, let's say, university teaching, so certainly not. But we are using robots for interacting in children in this project that I know of, this activity with autistic children. So there are about 2% of autistic people all over the world in the population. The
Right.
numbers have been increasing because we have now better diagnosis, and we are using these tools in therapy, early therapy stages, because we have well demonstrated that to some extent it has a positive impact on these kids' social development. And we are now moving to research on young adults with autism in order to use these technologies to build a more inclusive society and support their integration in
So,
workplace, for example.
so are these kids like any specially able, or do you have it? Are they any special type of kids? Or
I'm
Yeah,
sorry, I cannot understand the question now.
I mean, are they specially able kids, like, or are they normal kids?
If they are, sorry,
Are
the
they
sound is...
normal kids, like normal kids, or there's some special aspect to them?
essentially able.
Well,
Yeah, differently able, right?
these kids in particular, if I understood the question, so these kids they have different degrees of autism. So they are not neurotypical, they are not fully normal.
Okay,
Autism is very difficult because there is a very wide range of, so it's a spectrum of symptoms, and so every kid is a different case. And we have to personalize our technologies in order to try to adjust to the profile of each kid.
okay,
This is maybe, yeah, to the closest perhaps
mm,
to what you are suggesting. Thank you for the question.
okay, okay. Thank you very much.
Thank you.
Thank you very much, Professor. Ani ma'am?
Sir, thank you so much to Dr. José Victor for collaborating with us. And Adira is performing really good in computer vision field as well as in the robotics. And we expect many more collaborations to be done in future also. And in this forum, I invite you to SRM University also when time permits, so that we can have one-to-one interactions, and you can also visit our facilities and how far we can collaborate still more better. And there are so many government funded projects also we got in this specific area, and tie-ups with many industries too. So your expertise will definitely enrich us in these areas. So I welcome you as well as your team to SRM. Thank you so much for collaborating and your constant support and guidance. Thank you so much.
Thank you very much for your kind words, and I'm looking very much forward to visit SRM.
Definitely, this
And
will
I'm
be a
sure
great
we are learning from each other. Yeah, yeah, with pleasure. Yes, we should set this up. Yes, thank you.
Thank you.
Okay, thank you.
Okay, so it's okay, Dr.
Yeah.
Atira.
Yeah. So
Okay, I will.